You might think why we should use type. Maybe we can just use dictionaries to keep all the key and values, where we are using types to have the fields for each type. But there is a lot of other reasons. I'll show you one of them, and maybe we can discuss about a few of them more. So I put together what we have explored before. I put together that struct called band and the struct called album. So it's very common in large scale software development that you will access the field using a function which are called accessors, field accessors. So here I have created the field accessors which get name. So if we provide a value of type band, it get the name for that band. If you give a value of type album, it will get the name from the album. So now we have a band here, Dream Theater, and then now we have also an album here, also which has a name, and we can just use these get name functions to get the name. So I will just write that get name, and if I provide Dream Theater, it should return me the name, as I'm using the dot notation. And for the get name, and if I give the album name Systematic Chaos, it should give me the Systematic Chaos. So actually we can have, if you know that our objects are very similar and both can have name, both can have some other fields, even we can use the same name function all over our whole software. But as Julia has a dynamic dispatch, so by given the type, the function can be the same, but based on the type, it will dispatch the function we defined for that type. So if I quickly run those, and I will create that object. It creates the object, create that band object, and then I will also run that function. So it returns me the name, also that be not defined. The reason is, yep, so that should be album A, not B. So now we can get Systematic Chaos, the name of the album. So in real life, you can model more complex scenario. For example, as we know, the album belongs to some artist, like a band. So then our struct can be like that. So as we already have the band information, we can use that type as inside of that album, and that will be that can be considered as a composition. The way we inherit in object-oriented programming, the same way we can create type, we can add like types, our own types inside of another type. So I can rewrite that album, and then in the place of the artist, just only not the name, I can put the band type. So now when I will create the album, I can provide, in the place of artist, I can provide the whole band struct, and then we can couple those in our large scale software development. So we can model really complex stuff using this kind of chain, creating this kind of chain. But also you might think like, why not using dictionaries? That's one of the reasons not to use. But also another reason, like here we can see I have created two dictionaries. One is the Dream Theater band. I didn't give other parts because for now we are just interested in the name. And so there is a dictionary for the band name and there is a dictionary for the album name. But now, as both has same type, that both will accept same type. Now the field name are different for these two dictionaries. So we cannot use same function. So one can have access to that d.name and another have to have access to album name, not the name. So we have to create separate functions for them. If we redefine same function, then one will overwrite each other. So that's another reason not to use the dictionaries, because we can just define behaviors and still having the same name, and which does the same thing, but the object can be different every time. So it does the same thing, but based on the object it does. And other reason is in concurrent programming, there is a scenario called a race condition. I will not explain that detail because in that course we are not using any race condition stuff. So usually people try to avoid any kind of type which is mutable. For example, you can replace the values. For dictionary, you can easily replace the name with some other name, or the album name with some other name. But if you create a struct, like not mutable struct, you cannot change the names. So when you will run concurrent program, if different workers is accessing the same fields, by chance, by mistake, they won't be able to overwrite each other, because the type struct, which is not mutable, will throw error if they want to change the field, whatever is given in that field. So that's another reason. So you can read more detail about that race condition, and then more detail about types. I will put some link of the document about the types, and maybe you already had a look about the types when previously we have discussed, because I also put that document in that type. So you should study about that type by yourself to know more about it. Thanks for watching. I will see you in the next video.